Hey guys, welcome to TechNewsR. This is Rohit Sharma, and in this video we are going to revise our concepts related to AC bridges. Before this, we have completed our DC bridges and also the comparison between AC bridges and DC bridges. Okay, already we know that DC bridges are used to measure resistance and AC bridges are used to measure inductance, capacitance as well as frequency also. Okay, so before starting the video, I would like to request you all of you to please join our Telegram group, that is ISRO for ECE. Because daily many questions are solved there, and around 600 students are there in the group. Also, we have launched India's first test series for ISRO Technical Assistant Exam. Please register for this because around 1800 questions will be solved there. Okay, so let's start the video. First, what is an AC bridge? AC bridge is a modification of a Wheatstone bridge that we have studied in DC. An AC bridge consists of four arms, okay, a source of excitation, that is a voltage source, and a balance detector, okay, like this, something like this. Four arms are there and all are the impedances, okay, Z1, Z2, Z3, Z4, like this. And there will be a balance detector. Balance detector can be here, okay. Here the balance detector is replaced by a headphone oscillator, etc, etc. Okay, so in AC bridge, each of the four arms is an impedance and the battery, and the galvanometer of the Wheatstones are replaced by an AC source and a detector sensitive to a small alternating potential difference. Now, where can we use our AC bridges? First, we can measure our unknown impedances and the associated parameters like inductance, capacitance and resistance too. Also, we can measure the dissipation factor, that is also known as the reciprocal of quality factor, and we can also measure our electrical permittivity. Okay, as we know that capacitor is equal to epsilon naught A upon D. Therefore, if we can measure the capacitance, we can also measure the electrical permittivity. Also, we can measure the frequency. I will tell you the bridge which we use for measurement of frequency. Also, for phase shifting as feedback paths for amplifiers and oscillator and filtering of undesirable signal. Now here we have discussed the introduction of AC bridges and also the uses where we use our AC bridges. Okay, now first of all we have to measure our inductance in a bridge. To measure inductance in a bridge, total four bridges are used. First is Maxwell's bridge, Hayes bridge, Anderson's bridge and Owen's bridge. Okay, why Maxwell's is used? Maxwell's bridge are used for medium Q coils. Here you can measure the inductance only when the quality factor is between 1 to 10. Here the quality factor is greater than 10 for Hayes bridge. Okay, Hayes bridge is used for measuring inductance when quality factor is greater than 10. Okay, Anderson bridge is used for measuring inductance when quality factor is less than 1. Okay, remember that this can be a MCQ question in your ISRO Technical Assistant Exam. And Owen's bridge is used to measure self-inductance and also the incremental inductance. Now we will see the bridge, how they look like and how we can calculate inductance from that. Okay, now this is the Maxwell inductance bridge. Okay, here the R2 and L2 are the varying resistances and varying inductance. Okay, now we will equate our like this Z1 Z4 is equal to Z2 Z3. On equating this and by separating the real and imaginary part, you can calculate the resistance R1 and the L1. These are the unknown resistance and the unknown inductance. Okay, therefore resistance R1 is equal to R2 plus R2 the internal resistance of this into R3 by R4, and L1 is equal to R3 by R4 into L2. This is how for a Maxwell inductance bridge you can calculate the unknown resistance and inductance. Okay, now there is a advancement in this Maxwell inductance capacitance bridge. Here you can calculate the inductance in terms of capacitance. Okay, here we have taken a variable capacitance in parallel with the variable resistance. Okay, so for calculating the resistance, R1 is equal to R2 R3 by R4 and L1 is equal to R2 R3 C4. This is the Maxwell inductance capacitance bridge. Now comes our third bridge. Before third bridge, we will study the advantages of Maxwell inductance capacitance bridge. Okay, it is used for the measurement of wide range of inductance. Okay, you can measure wide range of inductance at audio and power frequencies. Okay, Disadvantage, what is the disadvantage? First, the cost is very high as a capacitor is used like this, which is very expensive. Okay, this is not suitable for high quality coils, high Q coils. Okay, this is not suitable. We cannot measure for high Q coils. Second, it is not suitable for measurement of low Q coils due to sliding balance problem occurs to satisfy the phase angle condition for bridge balance. Okay, now we will go to our third bridge, that is Hayes bridge. What is Hayes bridge? I have already told you for Q greater than 10 we use this Hayes bridge. It is used for the measurement of self inductance. Okay, in this the capacitance and resistance are in series. Okay, there is no variable resistance or variable capacitor in this. Okay, for this to calculate the unknown resistance and the unknown inductance, that is R1 and L1, these are the formula we can derive. Okay, I have not derived here because the derivation is not will not come in your paper. Only you have to remember these formulae if you have any numerical. Okay, by analyzing the previous year questions, I have not seen any numerical type question based upon bridges. Okay, only I have seen the bridge is used for the bridge which is used for measuring the self inductance, capacitance, frequency. Okay, I have seen these types of question. Okay, but you have to remember these formulas. Okay, now fourth one is Anderson's bridge. What is Anderson's bridge? It is a modification of Maxwell inductance capacitance bridge. In this we have connected a capacitance in shunt. Okay, in this method the self inductance is measured in terms of a standard capacitor. Therefore, to find the R1 and L1, these are the formulae for this. Okay, but only you have to remember why we use this Anderson bridge. What is it is a modification Maxwell inductance capacitance bridge. These type of question you have to remember. Okay, now fourth one is our Owen's bridge. Owen's bridge is used to measure the unknown value of inductance, also the incremental value of inductance. Okay, and this is the type of bridge. Here we have the variable resistance and the variable capacitor, and one more capacitor is here. Okay, if the question comes, name the bridge which have two capacitors, then Owen's bridge is the correct answer because there are two capacitors here. Okay, like these type of questions can be framed from here. Okay, this is the formula for calculating the resistance here. Now, how we can measure the capacitance? For measuring the capacitance, there are two types of bridges. First is the de-Sauty bridges and second is the Skirring bridges. Okay, before this, here the main thing is, here we have to calculate the dissipation factor, also given by 10 delta. Okay, it is the inverse of our quality factor, D is equal to 1 upon Q. Okay, de-Sauty bridge, it is the simplest method to compare two capacitances. Okay, to compare C1 and C2. This to compare two capacitances. Therefore, C1 is equal to C2 into R4 upon R3. Okay, but the disadvantage of this method is that the dissipation factor cannot be determined accurately. Therefore, we have made up a new bridge that is known as Skirring bridge, and in this we can measure easily the dissipation factor and also the unknown capacitances, and also we can find the relative permittivity. Okay, here you can see three capacitances are there, C1, C2 and C4 and R4 are parallel with each other. This is also known as low voltage Skirring bridge. Okay, now the next is how we can measure our frequency through bridges. Okay, the bridge which is used for measuring of frequency, that is the Vane's bridge. Okay, in this the capacitance and resistance are connected in parallel with each other and also in series with each other. Okay, the frequency, the formula frequency, please remember this formula. This is very important. Numerical based question can come here also. That is 1 upon 2 pi root of R1, R2, C1, C2. From here you can calculate our frequency. Okay, it is used for measurement of unknown frequency. From the known value of frequency, unknown value of capacitance can also be calculated. Please remember these points. Okay, these are the applications of this frequency bridge or Vane's bridge. Okay, last, what are the sources of error in bridge circuit? What are the errors because of which we have taken these bridges? Okay, the first error we can have in this is stray capacitance effect due to electrostatic potential difference. First, second, mutual inductance effect due to magnetic coupling between various components of the bridge. Third is the stray conductance effect, and fourth is the existence of small amount of series inductance or shunt capacitance in a non-reactive resistors. Okay, these four are the sources of errors which can obtain in a bridge circuit. Okay, please remember this can be an MCQ question. Okay, so please remember, I have taken that data in this PPT, which is very useful for our exam. Okay, so this is only about AC bridges. Okay, these are the various types of bridges in our AC, and we have now completed our bridges, in which we have also revised a concept based upon DC bridges, comparison between AC and DC, and also the concept of AC bridges. Okay, those who have any problem related to this, please join our Telegram group and discuss it there. And if you like the video, please share the video as much as possible, so that your friends can also get benefit from this. And also I will also feel motivated if you like the video and share the video. And also don't forget to subscribe the channel. Okay, so all the very best. We will meet in the next video. Okay, bye.